prime of 5 was 6. And then we're going to do minus 2, g prime of 5 was 2. 5 times 6 is 30. 2 times 2 is 4. So r prime of 5 is 26. On the next page, we're introduced to the idea of the product rule. So let me highlight product rule so that we can find it. And the product rule for derivatives is used when your function is made up of two or more functions that are multiplied together. So a general example is that y equals f of x times g of x. And then we have this rule right here. So this rule is definitely one to memorize. I have a bit of a graphic organizer, if you will, for remembering this rule. So what we have here is we have two functions, one function f of x, one function g of x multiplied together. So I can identify that I need to use the product rule because it's the product of two functions. What I'm going to do is take my two functions and in a little box, I'm going to put one function up here, the other function in the upper right-hand corner. Below them, I'm going to put their derivatives. And I'm going to start in the lower left-hand corner. And I'm going to do lower left times upper right, and that's what gets me this first term. And then I'm going to skip over with a plus sign, and I'm going to take the upper left times the lower right to get this piece of the function. So when we start using functions instead of just function notation, this can be very helpful in keeping things organized. But for now, the other thing that people remember is that this is the derivative of one of the functions and the regular part of the other function. And then you flip them. The regular part of one of the functions and the derivative of the other function. Okay? If you took math analysis last year, you may know first derivative of the second plus second derivative of the first, and you'll hear that quite a bit. So it's up to you the way you want to remember it. I tend to use the box just to try and keep things organized. Okay? So for the first example, this you'll recognize as one of the problems that we did on the page before. And I said there were two ways to do this. I'm going to look at this as if it is the product rule because I have a 3 times g of x. So I'm going to set up this box and I'm going to put the 3 in the upper left, g of x in the upper right. Well, we know from doing the previous page that the derivative of g is g prime, but we don't know the derivative of 3. However, what we do know is that derivative is slope. So I'm going to think of the function y equals 3. So y equals 3, let me sketch it over here. I'll do it in a different color. Y equals 3 is a horizontal line that passes through y equals 3. Well, if it's a horizontal line, the slope of a horizontal line is 0, which means that the derivative is 0. So when we have straight lines and it's really easy to determine the rise over run or determine the slope, we can calculate the derivative very easily. So then I'm going to start in the lower left-hand corner, and I'm going to do 0 times g of x. So I'll say h prime of x equals 0 times g of x. And then I'll add to that the other diagonal, 3 times g prime. And I'm running into a little space here. That's okay. I'll erase a little bit so that I can squeeze this in. Well, if I have 0 times g of x, this term is going away. H prime of x is just going to be 3 g prime of x. And so if I scroll back up real quick to the example that we did that was similar to this, right here, whoops, right here, we end up with the same thing. We end up with 3 times g prime of x as our derivative. And then to find h prime of 5, I'm going to say h prime of 5 equals 3 times g prime of 5. G prime of 5, according to the information that we're given, is 2. And 3 times 2 is 6, just like we got up on the page before. Next example, we've got our function k of x is f of x times g of x. So this one is pretty straightforward. This one looks just like the rule. So if we do our box, we get f of x in the upper left, g of x in the upper right, f prime in the lower left, g prime in the lower right. And to find k prime of x, I'll start in the lower left. I'll do f prime of x times g of x plus f of x, upper left, times g prime of x. Then to find k prime of 5, I'm going to do f prime of 5, g of 5, plus f of 5, g prime of 5. Evaluating, f prime of 5 is 6, g of 5 is negative 3, plus f of 5 is 1, g prime of 5 is 2. So we've got negative 18 plus 2, which means k prime of 5 is negative 16. In the next example, we're doing, instead of f of x times g of x, we're doing g of x times f of x. And I did this one on purpose because I wanted to see if I could change the order on the multiplication and still get the same derivative. So let's see what happens. So I'm going to set up my box and put g of x in the upper left this time, f of x in the upper right. So then I have g prime of x and f prime of x. So then y prime of x is going to be g prime of x, f of x, plus g of x, f prime of x. So far, if I take a look here at what we have, and I look back at the previous example, it looks very similar, except there's some terms that are flip-flopped. Let's keep going. So then I'm going to say y prime of 5 is g prime of 5, f of 5, plus g of 5, f prime of 5. And we'll go up to our given information. G prime of 5 is 2. F of 5 is 1. To that, we're going to add g of 5, which is negative 3, times f prime of 5, which is 6. So we have 2 plus negative 18, which is exactly the same as what we had before. which means that y prime of 5 is negative 16. So this tells us that the product rule is commutative. If we think back to our properties from Algebra 1, multiplication is commutative, you can change the order. Addition is commutative, you can change the order. And this rule has both. It has multiplication and uh, multiplication and addition in it. And so we can change the order and it's okay. Okay. The next example, we can look at this two different ways. So I can think of this as a negative 2 as one function, f of x is the second function, and g of x is the third function. But I'm not going to look at it that way. Instead, I'm going to put the negative 2 with the f of x. Because we saw with some of the previous examples that had the 3 in front that we can do that. So I'm going to take negative 2 f of x as one function, g of x as the other function. The derivative is going to be negative 2 f prime of x and g prime of x. So then to find m prime of x, I'm going to do negative 2 f prime of x, I'm starting in the lower left-hand corner, times g of x, plus negative 2 f of x times g prime of x. So that means m prime of 5 is going to be negative 2 f prime of 5, g of 5, plus negative 2 f of 5, g prime of 5. And if we look back at our given information, then we have negative 2 f prime of 5 is 6, g of 5 is negative 3, plus, we're going to do negative 2, f of 5 is 1, g prime of 5 is 2. So we have, let's see, 6 times 6, that looks like, so 36. And we've got a negative in here, so I'm going to go ahead and say minus 2 times 2 is 4. And 36 minus 4 gets us m prime of 5, which is 32. So we can do this with function notation. We can also do this like we did in the last section with tables. So I'm going to use information on two functions f and h to find g prime of 2. So g prime of x, I can use the little box and say f of x and h of x, f prime of x and h prime of x. And g prime of x is going to be f prime of x, starting in the lower left-hand corner, h of x, plus f of x times h prime of x. G prime of 2 then is f prime of 2, h of 2, plus f of 2, h prime of 2. And then we go up to our table. We're plugging in lots of 2's. So I'm looking primarily at this column right here. So f prime of 2, I'm going to go to my f column, or my f prime column, and look across, and I get 2. I'm going to do the same thing with h of 2, so I'm going to use my h column, look across, and I get negative 2, plus f of 2, so top row, all the way across to that yellow column, and I get 4. And then h prime of 2, bottom row, all the way across, and I get negative 1/4. So I've got negative 4, minus 1. So g prime of 2 is negative 5. We can also do this with graphs. So I've got a graph of two functions, f of x and g of x. G of x is the squiggly one, f of x is the absolute value function. And we're doing f of x times g of x. So the big function h is f of x times g of x. So the first thing I want is f prime of 3. Well, what I know is that derivative is slope. So I'm going to go to my function f, and I'm going to look up. So let me go to 3. 1, 2, 3. I'm going to look up to my function, and I want to know the slope of this line. Well, let's look at the bigger line, because it's all the same slope, because it's a straight line. And if I find the slope of that line, I'm going to go up 1, 2, and over 1, 2, 3. So I went up 2, I went over 3. So the slope at 3 is 2/3. I can do the same thing with g. Now g is a little squiggly, so we have to be careful until we get more information about how to take these derivatives. But if I go to 3 and I look up to my function g, I've got a turning point. So that little blue dot, that little light blue dot that I just put up there, is a turning point on the function. Well, if I run a tangent line on a turning point, it's a flat line. And so g prime of 3 is the slope of a horizontal line, which is 0. So this slope I'll label as 0 because it was a flat line. So then h prime of 3, well, let's find h prime of x first. So I'm going to say h prime of x equals, and this is the same derivative rule that we've been using. We've got f and g, so we can look to an example up above if we wanted to. But this is going to be f prime of x, g of x, plus f of x, g prime of x. So then h prime of 3 is f prime of 3, g of 3, plus f of 3, g prime of 3. Some of these values we have because we just found them. So f prime of 3 we know is 2/3. G of 3, well, we need to go to the graph. So what I need to do is go to 3, go up to g, and find the y value. Well, that y value looks like 1, 2, 3, 4, 5. So I'm going to go ahead and put in a 5. Then we're going to do plus f of 3. So I'm going to do the same thing. I'm going to start at 3. I'm going to go up to f. I'm going to go over. And this one we can kind of approximate. I'm going with 2/3. Well, okay, 1 and 2/3. So that's what? 3, 4, 5. Okay, so we'll say 5/3. And then g prime of 3 is 0. So that's why our little estimate is, it's okay if we're a little off, because guess what? That goes away. And I end up with 2/3 times 5. So 2 times 5 is 10 over 3 plus 0. So h prime of 3 is 10/3.